There we go. So if you don't feel comfortable being recorded, just keep your camera off. And go ahead, Steffi, sorry.
I think that's everything. So Sam, if you want to start.
All right.
Yeah.
Let's do it. Okay, cool. So yeah, hi everyone. I'm Sam, the co-founder and CTO at Oso. Really excited by what we're going to share with you today, and especially thanks to Andrew for joining us from Sesh. And I think we've also got Ben here from Sesh. So hey both. Cool. So I'm just going to do a little intro. Share my screen. Cool. Someone let me know if you can't see this. Yeah, so we were talking about basically how to make authorization fun. So just to ground everyone, make sure on the same page, we're going to talk about authentication versus authorization. So this is Alice. Say hi, Alice. So authentication would be the process where Alice goes and identifies like who she is. So you go to your website, you enter your username and password. This is Alice like proving that she is actually Alice because she knows the password. That piece is authentication. It's like, cool. Now the website knows that this is Alice. Authorization, on the other hand, is like, well, now that we know it's Alice, what can she do? What can she do inside my app, inside my products? So maybe, she can see her data, but, she goes and tries to see something from, I don't know, a different team or in a different project or something like that. Then maybe she'll get a page saying, sorry, you don't have permission to see this page. And that right there that's your authorization. Like, what can the user see? It's, what data can they read? What actions can they take? All of this kind of stuff. So what is it that makes authorization hard? I mean, it often starts out pretty simple. Like maybe this is your application data model. You have a bunch of users, they belong to some organizations, and there's some data they're trying to access. And like your authorization model at that point might just be like, well, based on their role, what can they do? An admin of the organization can invite other users, they can delete data, members can, read data, edit data, something like that. So it starts off like, okay. But like over time, you get new feature requests, you take on larger enterprises and they have new things they want you to support. So you start adding in projects, and now data belongs to projects, and you want to have different permissions within those projects. You start having like roles and things within the projects. And now your model is not quite so simple. You're trying to answer like, what can this user do? And now you start figuring out, well, it depends on what project they have, maybe it depends on what project the organization belongs to, and do they have a role for those, and so on. And it doesn't stop there. It just keeps growing and growing and growing, basically. So you have like other users from other organizations that you share certain projects with them, or maybe if you created a piece of data, then you're allowed to do certain things to it. So basically all of this we talk about as authorization modeling, and it's really around defining like the logic that backs like who can do what inside your app. And the challenge here is that like it can start out pretty simple, but over time it gets like more and more complex. And the challenge is like, you can either re-implement this like 3 or 4 different times, or you can try and build something that's kind of like simple to start with, but powerful as you grow. And it's a really hard balance to get. So yeah, I think this is kind of it's kind of piece one. And so this is something we'll be talking about a lot more today as well. Is like, how do you actually go about doing these things, like saying, user might have a role for a specific project. Okay, but that's the logic. That's like the authorization logic. Like, how do you make decisions? Then the next step is like, how do you actually go and enforce that in your app? Like, inside your application code, making sure that the user can't see the right certain piece of data, right? So maybe you have your user, they go and they access the website and goes and tries to read some document. But you just make sure it's authorized. So you add in extra few lines of code to check the user can do that. And now that piece of, that kind of line of code has been authorized, it's nice and secure. But of course, there's not just like one place in your app. There's going to be multiple places in your app, apps talking to the database, different layers of code, all this kinds of stuff. And again, this can be a real source of complexity. But it doesn't even stop there. Again, like actually it turns out that maybe just in the app code is not enough, because sometimes you might also want to do some enforcement when you're getting data from the database. Maybe you even want to bubble it up to your UI so that users can only see things they can do. You hide a delete button if they don't have permission to. So you kind of start with this thing. It's like, well, it's just a line of code, and it starts like spreading throughout your entire like application architecture. And this piece here might just be for like one app, like one Ruby web server or something. Over time, you might end up splitting these out to microservices. you might have multiple of these and they try to talk to each other. So now your authorization becomes sprawling across those. And this goes on and on and on until you become, like a Google or an Airbnb. You have like these giant systems that you're trying to scale, and you're trying to figure out like, how can I make authorization work like throughout this giant architecture? So those are some of the ideas of like the challenges of what makes authorization hard. Kind of the other half of our like talk here is like, well, what makes it fun? I kind of have two answers to this. Like I'm sort of biased, but I think just working on these hard problems itself are really fun. Like how do you actually go about and solve all these things? But it kind of is a slightly different view I have is like, well, that might be fun for us, but maybe not for everybody. And I think the pieces that can be fun about authorization is like figuring out, what do you want your app to actually do? Like, what do you want the user experience to be? What do you want them to, what features do you want to provide to them? What functionality do you want to enable? So on the first one, so going back to like the kind of the microservices setting where you have like multiple apps doing authorization, I sort of mentioned, as this grows over time, places maybe like Google or Airbnb, they've like gone and built their entire, like these whole systems around like solving this problem. Just kind of, it's an interesting problem. So I thought I'd just share with you a little piece of that. Basically what they did is they sort of have this like big central data store that like stores all that authorization data. And they're basically saying, we're going to use this to do authorization so we can handle across all of these apps. So if you go back to like the other diagram I have with all these arrows and things between things, basically what those kind of approaches at places like Google do, and the system they have is called Zanzibar, is it takes all these like little edges between things. Like a user has a role in an org, or a project belongs to an org, or a user created a piece of data. They take all of those like lines between your like application data, all those relationships, and they basically put them into that database. So they just have like a big table that stores like, Alice is a member of Acme, and Acme is the parent of project A, and Bob is an admin of project B, and so on and so on. So they like basically like take all that data, put it into that big central database. And by doing that, it kind of makes it easier to do authorization across those like multiple microservices. But it comes at kind of a severe cost. Like you've taken your nice like microservice setting with a bunch of separate apps, and you've kind of centralized them onto one big database. So we actually have a different approach at OSO. We basically said, well, you already have like your application code speaking to a database to get the data it needs. What if we just let you continue to leverage that data that you already have, right? So rather than like ask you to put it all into a separate system, just tell us how to get the data that lives inside your app. And basically from that, we're going to then let you just focus on what my authorization to do. So for example, you take something like the high level concept being like users can delete data if they're an owner of the parent project or the data kind of thing. And we kind of give you this like short syntax to say, delete if you're an owner on the parent. And those like little pieces of information there is all just getting pulled straight from your data model. So like, again, here's your like the messy application with all your different like, many data models between things. And basically this like short piece here is just using that existing information. We're saying, a user is an owner on a project, and the project is like a parent of the data. Then you're allowed to, delete the data. But that's just like all being built off of your application models and your applications. So this is kind of like the general idea of like how we're trying to make authorization fun. I'd say is like on one hand we're building some interesting stuff to solve some of these interesting problems. But I think for like users of OSO, the idea is that you just get to focus on like, what do I want my app to do? And a big part of that has been enabled by a feature we have called resource blocks that I'm going to hand over to Graham Kemmer in a second to talk through. So just as a little intro, Graham is an esteemed OSO engineer. He is, actually I've got a question before I move on. And then you'll get your intro, Graham. Yeah, Tyler.
Yeah, good introduction. When you're talking about like applications and adding authorization there, are you talking mainly about like client front-end applications, or is it more like back-end API, business logic, or is it both?
Yeah, great question. So primarily I'd say I'm talking about back-end applications. So this is the kind of logic you see very typically in B2B SaaS applications, you know,
Right.
the backend web server that's driving all that logic.
Many front end applications kind of labeled for each different kind of company, but then the decision logic is happening at the API level.
Right, exactly. But as I said, you know, you do sometimes get this kind of authorization trickling into, you know, into the front ends. You want your UI to be kind of authorization aware. Like, should I show this piece of information to the user or not? Like things like that.
Right. Thank you.
Any other questions before we move on? All right, so once again, I'm going to hand it over to our esteemed OSO engineer, Graham Kemmer, who, among many other incredible contributions, I think one that stands out is he built probably the hottest React authorization interactive demo in the land. Graham, take it away.
It's hard to make an interactive demo for something as sort of backstage as authorization, but thank you, Sam. I am also going to share my screen. I sort of my goal is to, you know, take what Sam said, and I think there's a good intro to sort of the problems of authorization in applications. Oh boy, let me go back to my first slide there. A good overview of the problems in authorization, but the actually, let me get I'm missing a window here. That's okay. And I'll talk a little bit about how like go a little bit deeper into one of those common authorization models. Role-based access control is, you know, this model that is shared among many apps, especially sort of software as a service B2B style apps. And also go a little bit more into detail on that and speak to how OSO, how we used our configuration language called Polar to very easily model this type of authorization using your existing application data. So I believe, yes, you can all see my screen here, and we have like a pretty simple diagram of what you know, basic B2B situation would be like. I have kind of a GitHub style application modeled here where, you know, a user has an owner role on an organization, and then that organization contains maybe 2 repositories. So repo 1 and repo 2. And so, you know, in this model, it's pretty easy to reason about permissions that this user might have on these repositories. And it can be kind of helpful to think about the, you know, implied roles that the user has on that repository. So because the user has, you know, an owner role on an organization, it sort of is implied that they are an admin of these repos, and the permissions that your application might grant to that user would include, like, you know, all admin permissions, maybe read, update, and delete. And that's pretty easy to do implicitly. You know, if you're just getting started, you could, wherever you need to in your application code, if you know you want to check an update permission on a repository, it's pretty easy to just look at the repository's organization and actually query the database for the roles that the user might have on that organization, and then check that the role matches some subset of roles that grant the update permission. And so that would be like code that you might write if you were building an MVP for a B2B SaaS app, or if you only had to support this sort of top level role concept. But as Sam mentioned in the last talk, it often kind of gets more complicated than this, and so we want to, you know, with OSO, we want to support models like this. This is a simple model, but we also want to support models as they get more complex. And so as you know, similar to Sam's example, here you know, we're imagining a scenario similar to GitHub where, in addition to having a role on the organization, which grants you roles on repositories that live within that organization, we also allow users to be granted roles to particular repositories. So in this case, our user, who's an owner on this organization, is also granted the maintainer role on a separate repository that belongs presumably to another organization, whose maybe perhaps admin has granted this user this role in the UI or something like that. But now, to do that same check that I was talking about before, where you check if a repository, if the user can update a repository, essentially, the actual communication with your database is more complicated. You not only have to check now the roles table on the organization that owns that repo, so you have to walk up, you have to grab the repo's organization and check the role. That's what we were doing before. But you also have to check all of the users' roles on the organization in question. And that starts to, you wouldn't want to be doing that everywhere that you are checking these permissions, obviously. That's a lot of, that's sort of a, you want to encapsulate the sort of sharing logic into one place and have one place where you sort of model, okay, this is how these objects relate, and this is how roles flow between different objects. Just to give another example, I don't think, it doesn't end just with one level of nesting. Here we have a really similar setup that's not GitHub related, but where a user has an admin role on a tenant or an organization. And then it's, we have a project inside of that organization, and then inside of that project, there's a document, and roles kind of flow down the tree, and you can see like permissions likewise flow down this sort of tree from the user. So and perhaps you have a viewer role on this document, and that grants you only read. But now to check permissions on documents, you need to not only you don't need to walk up just one level on the tree to check roles, you need to walk up multiple levels and then load roles based on that. So this is where authorization code, practically gets complicated, is when you start having all of these implications. What is the name of the role? What is the name of the role in the project might depend on the role on the tenant. How do we make sure that your implied role here that's called editor sort of grants you the same role or grants you the same permissions that would be granted to you if somebody shared you as an editor. Those are all sort of questions that we set out to solve in building sort of more of a roles-centric syntax for OSA's authorization language. So to model something, to model something like this, this previous slide, we allow you to kind of, and again, this is something that Sam mentioned, but we allow you to structure your authorization logic by resource, and tell us, explicitly which roles a user can have for each resource, and then based on those roles, what permissions they are granted. Another important thing is that we also let you define relationships between objects. So we have, users can have roles on objects. Objects can have relations with other objects. So here it's pretty important that repositories live inside of organizations. And then you can write implications for permissions based on those relationships. So the key thing here is this, if I am an owner on the parent organization for a repository, I inherit the maintainer role on the repository itself. If I am a member on the parent organization, which is a lower role than the owner, I inherit the viewer role on this repository. And so those are the type of implications. You sort of write all of your roles, you write all of your permissions, you write all of your relationships, and then you write implications over those in an OSO policy. And then the sort of glue, the glue that you have to write in order to have that actually work are what we call has relation, has role rules. And those actually, to actually feed into the, the implication system, you tell us how to actually treat your data as roles, how to treat your data as relations. So here we say that an org is the parent to a repository if that repository's organization is equal to the org. Similarly, we are able to fetch, we in order to determine whether a user has a repository role, we look through a repository roles field on the user to see if the role matches that particular repository and that particular name. And obviously there's like some syntactic detail here that I don't need to go into. It's not super important, but the basic idea is that you define a policy, that you define these implications, you define the way that permissions flow through your graph of objects, and then you define how that graph should actually be populated based on your data. And with that, OSO is able to quite easily make authorization decisions anywhere where you might need them. So this feature is something we call resource blocks, and it's simplified, a lot of these types of models, and like reduce the amount of code you have to write to actually implement those models. And I think, yeah, hopefully that is a good introduction to that particular feature. I know I'm excited to hear from Andrew. I know he's going to talk a little bit about how Sesh uses OSO and how resource blocks and sort of the OSO mental model helped. Well, I don't want to set him up too much, but
spoilers.
Yeah, but the model is helpful in building lots of different types of authorization systems, and so looking forward to hearing from Andrew on that. What do we think? Do we think I should, if anyone has questions, perhaps maybe leave them in the chat or hold them in your head, and then we can answer them afterwards? What do you think, Steffi?
Up to you. If there's some like urgent questions that you might forget, you can ask them, drop them in the chat before we move on. If not, we can go on to a little icebreaker.
So I do have a question, but I also have to drop like now. But I can go back and watch the recording. One of the things I ran into is naming. Like if you name something as like somebody as a maintainer, and then you decide to change that name later down the road, like how does OSO account for that without having to like rewrite, your database tables and everything like that? So that's my question. Thank you. I have to go though. Sorry.
Thanks, Tyler.
Bye, Tyler.
We'll answer on the recording.
Yeah, it's a good question. I mean, what I would recommend there is that you can sort of gracefully migrate to a new role name by having the old role. So if you're renaming maintainer to admin, for example, you could do something where you write a rule that says that you write a rule called admin if maintainer, and that way you say, if you have the maintainer or if you have the maintainer role, you also have the admin role. And then you can start slowly migrating all of your databases to use the admin string instead of the maintainer string. And during that cutover period, the old maintainer roles will imply the new admin roles. And I hope that kind of answers that question. But the idea is that you can your policy exists as code, so you can update your policy, and then it sort of lives separately from the data itself. So
great question. I hadn't thought of that before.
Yeah.
We have another hand.
Hey guys, great work also. So I was wondering that the structure that you're providing, it feels more, it has to do more than definition. For example, more than a JSON or an XML definition, it has to handle a lot more logic. So it feels like it has to be Turing complete. So can we achieve a Turing complete level of handling in such short way? And also, for example, like there can be multiple use cases, B to B to C, and more kind of use cases that I can't even think of. So you think we can handle it in such simple logics? And another thing is, what is the most complicated scenario that you faced and also has overcome it?
What a fantastic question. So basically the kind of the thing underlying everything that Graham showed you is actually called the Polar language. So the kind of core piece that you write policies in, called Polar, is actually a logic-based programming language. So it is incredibly powerful. It is Turing complete. It's actually been built to handle kinds of like crazy complexity and things like that you could need. And basically the resource blocks piece that Graham was showing you was like specifically something we built on top of that language to like simplify and kind of provide a sort of our opinionated version of what we think you need for like most authorization logic. And you asked about like different use cases as well, like B2B, B2B2C and things like that. So like kind of what we've seen is I think virtually every single B2B app will use some combination of like roles and maybe some amount of relationships. And so that's kind of what we baked in front and center. But because it is powered by this logic language, it's actually super flexible. So you can, we have people implementing like custom IAM systems inside OSO where they're kind of, users are able to be assigned arbitrary policies that say you can read these resources if they belong to this project and it has this attribute and the user has this thing and the string subset matches this thing. It's like, it kind of enables like all kinds of use cases. And that's all kind of powered by that policy language underneath the hood. But we kind of didn't want to just expose that to everyone. We didn't want that just to be like the only thing you could use. So we built this kind of cleaner, in our opinion, sort of cleaner, simpler abstraction on top. That's a great question.
Sounds great, yeah.
Ron, you have a question?
Yeah, sorry, quick question. So you've shown us the really nicely kind of very clean interface that you've developed that sort of imposes a nice mental model for developers to think about authorization. While you were describing that, I was trying to imagine what the data looks like that's behind it and where that lives. And so maybe you're going to talk about this, but I'm just curious about whether the library dictates what that schema should look like, or whether it's agnostic of the schema itself. And if so, then how does it interact with any sort of flexible backend?
Yeah, so I think we basically, and Graham touched on this, we had like the has role, has relation kind of interfaces. We basically say you should structure your data as like things like user has a role in a resource, or a resource is related to another resource. And as long as you can express your data in that shape, then everything we provide kind of like composes together nicely. But you might have that in a NoSQL MongoDB database. You might have that in a many-to-many table. Like, we don't really care. Like our like data integration will kind of handle that, and it just kind of like plugs into the policy. So we try and provide that separation. It's like we have an interface for the application data, and if you use that interface, you can use the policy models.
Got it. And so somewhere there's a mapping, right? There's some layer. And so do I as a developer have to tell you, okay, so I say this is where my my users are called this field and they live over here, and the relationships table is called this, and here's where it is, and then you can handle all the logic around that. Is that how to think about it?
That's right. Yeah, exactly.
Yeah, and actually, I'll go into a specific example for Sesh of how we specifically hooked in using Polar and solved our auth needs.
Oh, sweet, awesome, thank you.
I see one more question,
sorry.
and I just want to address. I think we can come back to that one in FAQ because I think it could be a long, meaty one. But yeah, I do see your question, Zhao, and we can get back to that one at the end. Because yeah, I do want to hand over to Andrew.
Great. Hi, everyone. I'm Andrew. I work on Sesh, which is a smart meeting agenda meeting software tool. I'll give you a little bit of background about myself. I'll sort of talk about how we at Sesh used OSO to implement or basically like level up our authorization. And I'll start off by giving like a quick demo of our product so you get a concept of the types of resources that we're dealing with, and then talk about our journey going from sort of a piecemeal self-made authorization model to something that's a tiny bit more consistent and much easier to understand using OSO. So without further ado, I'm going to share my screen because that's what we like to do in Zoom. So this is basically, this is a view of Sesh. We got 4 people in a meeting here. There are sort of smart agenda blocks, different activities that you can use, some of which are interactive. All of it is real time. And for me, I like to use Sesh. For me, it gives you, it makes me a lot more present around how time works in a meeting, and also solves a lot of problems in terms of helping people stay on track, also helping the meeting be more inclusive, and a lot more fun to run. So we're going to start off with an icebreaker. So this is one of our activities that kind of does a sort of a round with a prompt. We have another one that just does a round, but we're going to do, this is a 1-minute thing, so we're going to do this real quickly. As a kid, what did you want to be when you grew up?
An astronaut. Boom.
Nice.
Nailed it.
Nailed it.
Oh, my turn. I wanted to be a plastic surgeon.
Ooh.
I did.
Stuffy.
I did.
So 2 things. One, I wanted to be a fireman, but specifically, I wanted to be a fireman called Harry Sam.
All right. I wanted to be 2 things. I wanted to be a paleontologist, or I wanted to work at McDonald's.
Love it.
So those are the important things. Now, I've specifically made this really, really short to sort of showcase the timing. Obviously, having 7 seconds to talk is a little bit stressful. But at around 30 seconds, although I don't know if I'm actually sharing my sound, so that could be, oh, there we go. Are you hearing that or no? Anyway, you get played off after about 30 seconds. It's a fun thing. Sort of like the Oscars. All right, Aaron, we want to...
Oh, I wanted to be a doctor or a teacher.
Oh, amazing. Okay. So, I will stop sharing this right now. So for us, we have a few different authorization needs for Sesh. We're just about to start launching teams. So we were in this period, as sort of Sam talked about, of going from a sort of small, simple modeled authorization to things getting a little bit more complicated. So for us, like we're going to start supporting multiple teams, different roles within those teams, and then within the meeting itself, you have hosts, you have attendees, you have also 3 types of users as well for us. We have logged out users. We have this notion of like a guest user, so someone that hasn't actually signed up yet but is just joining a meeting very easily. And then we have our normal logged in users. So we needed to come up with an intersection for all of these different user types, these different roles within a meeting, and we needed that to be able to scale so that as we layer teams on top of that, things just don't get into a giant soup. Before we found OSO, we had just been basically like hard coding auth checks in our API. We use we have a sort of standard Svelte front end, Go backend, and we started running into issues as the surface area of our app started growing, as we started doing, we have a native Zoom integration. We started finding holes in our authorization where like, oh, we added another action that you can perform, but we forgot to add the check to do authorization, which then had pretty big implications because we don't want to accidentally show your meeting to people that shouldn't be there. So we started looking down this process of how can we kind of centralize, or how can we streamline this process so we're not leaving holes in our authorization, and how can we scale up as we start getting more complicated, both code-wise and conceptually. And we ran into a wall because there just, at least when we were looking, or when I was looking, there just wasn't even like a good, like there's a lot of stuff about like role-based access control on the web, a lot of very simplistic guidelines of like, oh, well, you have a moderator or an admin and you want to restrict things, or you want someone to log in to a certain section of your website in 1994. So for us though, because we have this, we wanted this resource-based access control where you have per meeting access control. We wanted to figure out a way that we could implement this easily. And then we ran into the Authorization Academy at OSO, which conceptually helped sort of get things straight in terms of how detailed do we want to get? What are the best practices? Should we be genericizing everything and throwing it into a big data store? Should we, how do we even think about this? So we also tried like Casbin, which is sort of like the main Golang sort of authorization library. But that was like, it felt like too static. And also the support was really, really not great, the response time, to even start thinking about like, well, do I want to be doing authorization on our routes? Do I want to be doing it on our models? How do we inform our UI about this? All these questions were really difficult to answer. And then we found OSO, and everything was easy, and we're done. No. So what we ended up doing, and I'll share my screen here, was building out this OSO file, this Polar file. And I'll share this so you can sort of see specifically how we solved a lot of these problems. Okay. So this is basically like this one file, because I haven't gotten around to splitting it into multiple files, is basically like the core authorization that we currently have in our app. And we'll scale up when we need to support teams, which we haven't started working on yet. So up here, we have our notion of users, which I'll talk about in a little bit. But here's like our main meeting resource. And this looks similar to what you saw before. We have all these different permissions that you can do here. And we have these different roles where, so some of these are like very meeting specific, like host or attendee. And some of them are more user-based, like guest or logged in, because there's certain things we want to be able to do depending on the global user. And then we even were able to easily implement a sort of service worker. So we have like a job that runs that automatically stops your meeting if you've forgotten to do that, so it doesn't run for 6 days. And so we were able to also model that kind of permissions as well, all in one major file here. So it's fairly easy to read. And the lovely thing about this is that I was able to show this to like a junior engineer, and they were able to get on board within a day. You can start a meeting if you're a host, you can stop it if you're a host. You have different things that you can do if you're an attendee. Here's this relationship between like a meeting set, although I'm not going to go into that. And then specifically to kind of answer the question before, it's like, how does this actually hook into our data? We have, one second, where did it go? Hasbro right here. So we have all of these things set up where we're like, okay, you can do this if you're a host on a meeting. You can do this if you're an attendee on a meeting. But how do you know if the particular user is a host or is an attendee on the meeting? That's what this rule does here, I guess. Rule? Statement? I don't remember. Rule. There we go. So we say db.user has meeting role, which is a receiver that I set up specifically for auth that basically just passes along the different pieces of information looks into our the existing tables that we had already set up, because we already had this idea of who is a user, or sorry, who's a host, who is an attendee, and we can then this will then just hook directly into our database. Now, like we sort of said, this could live in Memcache, this could live somewhere else, but for us, because we had already written some of our authorization already, this provided a really great stepping stone. It met us sort of where we were at in our auth process, because we didn't have to like genericize and rework everything. We could still use the tables and a lot of the even business logic that we already had, but we could consolidate it in a really easy to read way. And that was really super important to us, because we wanted something that was powerful enough that we could grow and add extra complexity to, but wasn't so far away from where we were at that we couldn't do a lot more experimentation, because we're not entirely sure how the teams are going to work in terms of what they can do, and we're still trying a bunch of experiments. So the nice thing about this is that if we need to define a new relationship, we can. All we have to do is just throw in a new method that hooks into our existing data or uses a different data source. But all of it sort of lives in one place, and it's all easy to read and easier for us to understand. Oh, are we like making sure that we don't have holes in our auth? The last piece of the puzzle for us was also then, I would say like the major piece of the puzzle about this, and why we really, why OSO was like so useful for us, not to be like super sycophantic, but was the support that we got, right? So I was shocked to see how responsive, and I think probably many of the people on this Zoom have also seen this, how responsive the Slack was. It's kind of spoiled me for other frameworks, because now as I'm like implementing other pieces, and I don't have a community to think about like, well, what's a best practice or what's a good way to conceptually think about this? It feels like you're sort of out in the woods. But for us, it was really, really useful for us to tap into that Slack community to talk about like, well, is it better for us to just do this on a, like for example, to do our authorization just on our routes, right? Or is it better to do it closer to our data model? And we settled on doing it closer to our data model because it gave us a little bit more finer grained control. And as things inevitably got more complex, we were able to more granularly control like what you can do and what you can't do than you would if you just were doing everything on like, oh, can I access this route? Do I need to be logged in on this route or not? So, I mean, that's the basic gist. I talked a lot very quickly. And so, but it really was like, it was really easy to, easy to implement, and kind of a joy, to be honest. That's it. I'm going to drop the mic now.
Thanks, Andrew. I've still got Sesh up, so you actually seems like you finished early.
Thank you, Andrew.
Yeah, that was awesome. Thank you for sharing.
I think now we want to move into the Q&A because we only have 9 minutes left. Joao asked a question in the chat earlier. Joao, do you want to ask the question or do you want me to ask it for you?
If my mic works, I can ask the question.
Okay.
Sounds good.
So, hey, hi. Thanks for this session. So yes, we lightly touched on Zanzibar type systems, right? So I'm working on a service-oriented architecture system. It's not like microsystems, but microservices. But I have several systems in my system. Let's put it like this. And I've read your blog posts, but I still struggle to understand what is your proposed approach to essentially make this data available to the different systems as you need to make authorization decisions in several systems. So that's pretty much my question.
Yeah, it's a great question. It's one we're super interested in. We've actually been doing a bunch of additional conversations with people on this specific topic. So we'd love to follow up afterwards as well and talk more. Just to give you a brief version, we typically see, I'd say kind of two main patterns. Kind of number one, which I think can work in a lot of situations and is pretty easy to get working, is to have something like a central user management system that, you know, for a user with like, if a user has like a role on an organization, that role gets put onto something like a token so that it can be like shared between multiple services. So you can imagine, you know, a user goes and speaks to the, I don't know, say repository service, sticking with the GitHub model. You know, first they go to the user management service, get a token that says, you know, they're a member of this org, and then they go and talk to the repository service. And from there, you know, the repository service can like locally make a decision because it has that role data. It's kind of like one way of distributing that data. Now, a challenge with that is that, you know, sometimes the data you want to share between services is so much that it just won't fit on a token. And so generally our best practice for addressing that kind of situation is you can use some of the OSO like APIs to expose like pretty detailed like authorization data between services. So what that kind of looks like is you might take, and let's say you have like users, projects, and teams on your user management service. You could use OSO to kind of like expose like what roles of permissions a user has on those resources. You can kind of expose it via API to other services. So downstream service might query that and say like, hey, what role does the user have on this project? Gets that data back, and then it can make a decision. That's kind of like the general approach. And kind of what that allows you to do is each individual service like maintains and manages its own data. So instead of trying to like centralize and put everything in one place, you get to keep it in the individual services. And we basically just make it easier for you to like fetch the data you need when you need to make that authorization decision. But it will make that extra request. And so then you have to kind of manage and deal with like the latency of going out and making that like extra hop. We've basically been doing some kind of like internal thinking around like how we could actually make that set up, you know, even better for users. Maybe helping with something like the, you know, the caching side of things or building a service. So we would actually love to continue the conversation and kind of dig into that a little bit more, maybe in a separate call. It's a great question though.
Thank you. Thank you so much.
Thank you. Also, I just dropped a link so that you could get some limited edition swag. But I'm going to let Atul ask his question.
Thank you. My name is Atul Sharma, and I am working on a quality management system for specifically biopharma industry in manufacturing. And we have a unique sort of authorization problem. So we have dynamic roles, right? So that means, you know, there's a kind of a God user who can create roles, and to those roles, they can assign sort of permissions to different modules and whatnot, right? So that's one. And second is that the architecture is basically meta-driven architecture. So you can actually add your own new modules as well, right? You define the table structure, you know, something like, you know, what Power Apps does. So what I see in the Polar language is that in the resource blocks, it is very role-centric, and roles are kind of hard-coded in the Polar, right? So do we, when we make a new role, do we write the, you know, overwrite the Polar file and somehow, is it hot reloadable? Or, I mean, how would this architecture work?
Yeah, so I think to be honest, for such a dynamic setup like that, the resource blocks probably aren't the way to go. Those are kind of heavily optimized for, you know, applications with, you know, number of resources, orgs, projects, teams, things like that. Much like Andrew's app. But I think what's kind of nice about them is that all they are is just like a kind of a simple layer on top of the underlying Polar code, which itself is like, can be highly dynamic. Won't be able to answer this on this call, but definitely follow up in the Slack. But, you know, we can kind of help maybe guide you through what the policy for that would look like.
Okay.
But ultimately, you can use the same structure that we use for resource blocks, the kind of has role, has relation, composing them together. All of that's like underlying kind of low-level implementation would work just fine for like a more dynamic setup. It just won't be quite so out of the box like it would be for others.
Okay, and is it easily integratable with, we are using the Actix framework written in Rust, right? For our backend APIs. So is it easily usable there? Because I could find a lot of documentation using Python, but not much, using any Rust framework on OSO website. I did find some, GitHub resources, but not too detailed there.
Yeah, I mean we have a Rust library, so all the same policy stuff will work just fine in Rust. We just have honestly, we just have fewer examples for Rust, but a lot of the same policy stuff will work. Yeah.
Okay, I'll follow up on Slack with you then.
That would be awesome. Looking forward to it.
Thank you.
We're internally big fans of Rust. The core of the whole thing is built in Rust as well.
Oh, cool. Thank you.
Any other questions? Okay, we will end right on time. That's amazing.
That's fantastic.
Very surprised. Well, thank you all so much for coming. We're hoping we can do this again sometime soon. And we hope you had some like takeaways that you can take back to your teams and your friends who also share a fondness for authorization systems. If you want to continue the conversation, like please join our Slack community. I think I dropped it in there, but maybe Steffi or GK can drop it, drop the link. And then also thank you so much, Andrew. It's been so much fun.
Thank you.
I'm so jealous I don't get to work with you, but it's been great. Do you want to tell everyone about Sesh and where to find you?
Sure, yeah. So yeah, absolutely. Yeah. So we're still in open beta right now until the end of the year. If you think that if you want to run better meetings at your company, and on a personal plug note, I stream every Tuesday puzzle games on Twitch under Andrew is Trying. So I'd love.
I just dropped the link for you.
Yeah, it's just a little baby channel right now, so I'm hoping to make affiliate by the end of the year. So
thank you so much. Thanks
everyone for coming. It's a lot of fun.
Thanks for coming, everyone.
That was really fun.
Bye.
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 Bye.